right, trig functions in the coordinate plane and Pythag identity. We ran out of room to write that. Pythag identity. Can you put those two things away from me? Yeah. Just a public thing. All right, question. How many of you thought yesterday's homework was okay? But not too bad. The front part. I don't really care about the back. The front. Okay. How many of you like yesterday was pretty easy? All right. We're going to just build on yesterday. Do you understand? You didn't understand yesterday. You didn't do yesterday's homework. Today's going to be very difficult. Yes, please. An ice cream cake?
Not sure your cake.
Oh, well, the chocolate one?
Mm-hmm.
Okay.
No, when I actually get that, you better put it on your desk.
I will.
Okay.
$27? Today's, I don't know, it feels like Friday, but it doesn't feel like Friday. Yesterday felt like Friday.
It's not frustrating.
That is.
When she has kids, like they'll look like me, and then when I go like, "This is my mom," people actually believe me. Isn't that smart though? That's so smart. Like no one ever does that. No one's ever gonna look out for you like I do. Right, but you kill two birds with one stone. She gets a man, I get a mom and a dad. But like one like has like a cool name because I don't like black people's name like David and Kevin and weird stuff like that.
Those are normal names.
Yeah, you know, like something like cool like Taquan. Like,
Oh no. We're done.
We call him like my cousin's name is like Perry. We call him like I don't know what we call him actually. Like my cousin's name is like Jamon, but we call him Deuce. I have a cousin named Raymond. We call him Lil Ray, Ray Reezy, Ray 2. We call one of my cousins Oxygen and 2 of them.
Days ago, I lie. We talked about the X and Y axis, yes? We talked about all 4 quadrants. So where's quadrant 1 located?
Top right.
Top right. Where's quadrant 2? Top left. Quadrant 3? Bottom left. And quadrant 4. Good. This is going to play a key feature today. I can speak. All right. God bless you. In quadrant 1, what is your X values, positive or negative? And your Y values? Good. In quadrant 2? Negative what? Negative what? X and positive Y. In third quadrant? Negative X and? Good. Fourth quadrant? Positive X and negative Y. Yes? Now, this plays a key when it comes to something in a little bit, okay? You have to know what is what in that spot. Make sense? I'm just telling you that and giving you a fair warning. You do need to know what's negative and what's positive when we get to it. We're going to write steps. For how to solve these problems. There are 3 steps. They seem very similar to yesterday. Step 1 is draw the triangle based, it's the door, on the trig function in the given quadrant. Draw the triangle based on the given trig function in the given quadrant. Step 2. Use Pythagorean theorem to find the missing side. Notice I did not say hypotenuse. Yesterday was only the hypotenuse, correct? Today is not necessarily the hypotenuse. And step 3. Why is your jaw? Find the missing trig ratios. Your mom, yeah?
Are you going tomorrow?
Alright. So find the missing trig ratios. Do you understand the steps? Do they sound very similar to yesterday? Right? The difference yesterday was it only said hypotenuse. Today it's any side. And I'm going to show you why that changes right now. Let's do examples. We're going to call it example 1, but we're going to have 3 of them. That's cute. Or it couldn't be.
I believe I know that my little brothers look like that. They look like baby Jesus. I swear.
So I'm giving you sine of theta, and sine of theta is equal to 5 over 12 in Q1. What do you think Q1 stands for? It is. It's quadrant 1. So make a note that Q stands for quadrant.
Except for like when you start drawing your own triangle, and then that's, you know, and you scare me still, so that's why it's not scary. Listen, if you scare me, I know you scare them. And I spend time, I come here every day, at least 3 times a week. You going to the club tonight?
No. All right. Here we go. We're in quadrant 1, yes? Okay. Yesterday it looked different. Yesterday we gave you a what? I gave you a point because it formed a line, right? We had like a ray. Yeah, we're going to make a triangle. Same thing as yesterday. So watch. We're in quadrant 1. Make sense? Still make it in terms of your x-axis. So there's my triangle. There's my theta. Right? That's the same as yesterday. True? Okay. Now, pay attention. Sine of theta is 5 over 12. What does it mean to be 5? What does 5 represent? There's 3 sides of a triangle. What side does 5 represent? The opposite. What does 12 represent? The hypotenuse. True? Okay. So looking at my triangle, if I have theta here, the opposite of theta, is it the base, the height, or the hypotenuse? It's the height, which is 5. But I know the hypotenuse now, and the hypotenuse is what? It's 12. See how it's different than yesterday? Okay? But it's very similar. So now, that was step 1. Step 2 says to use what? Pythagorean theorem to find the missing side. Alright, so what is Pythagorean theorem? Is she right? Okay. Let's plug in. What do we know?
C squared.
What is C?
12.
It is 12. Equals, what's A?
5.
5 squared. What's B? B or X. I'm going to call it X today. Same thing, but I'll call it X. Alright, what is 12 squared?
44.
What is 5 squared? What do we do now? Subtract 25, and what do you get? 119 equals X squared.
That's not.
You just want to be a nurse.
Now what? What do you do now? Square root it. You can try the radical. Does anything go into 119? No, I'm going to tell you right now, nothing does. So I get X equals radical 119. Anything new? No. Now what's next? What does it say? Find the missing what? No, that's not what it says. Find the missing trig ratios. So how do we find trig ratios? Draw a what? A table. Sine of theta, cosine theta, tangent theta. Fill in your table. What'd you put in for opposite? What'd you put in for hypotenuse? Well, yeah, that should be the same because they gave us that, right? What's your adjacent? Radical 119 and radical 119, yes? Okay, so this is radical 119 that I found. All right, what's next? You solve. Well, we need to set them up. We already know sine, so I don't need to find that one. It's already there, yes? So what's the next one? So cosine theta equals radical 119 over 12. Is there anything I can do with that? Yes or no? Yes or no? Okay, so no. Put a box around it. Some of you are looking at me like I'm crazy and like it was a trick question. Tangent theta equals what? 5 over radical 119. Besides Diane, tell me what to do. Where? Where? Top and bottom. Good. Okay. So tangent theta equals what? 5 radical 119 over 119. Does anything simplify? Do I have my answer? Okay. Am I done with notes? No. Am I? Sorry. Does it make sense? Kinda? Very similar to yesterday? Yeah. Yeah. So today you're getting one given. Yesterday was just I give you x and y, which is technically tangent. I don't know if you noticed. It was tangent every single time. So now I'm giving you not x and y. I'm giving you one of the trig functions. Ready? Let's do more. Because I'm going to trick you. So what I want you to do is this. I want you to draw the quadrant. And I'm going to give you the trig function. And I want you to label your triangle, and then I want you to stop. So tangent theta equals,
Did you hear that?
it's my phone, 24 over 7 in quadrant 3. Picture looks like this, yes? I should have moved my x-axis up, but I didn't. Whatever. Where are we at? Quadrant 3. Top, bottom, left, right? Bottom left. Yes? Wonderful. Theta is on the inside. Now what? Where is 24 located? Is it the base, the height, or the hypotenuse? It's the height. 7 is located on the base. Question, what quadrant are you in? The third. What do you know about the third quadrant? What's negative? Not everything. Your x and your y. So should 7 be negative? Should 24 be negative? Okay. Why is it positive here? Does 2 negatives make it positive? So even though I don't write negatives here, I need to know what's negative based on the quadrant. Remember I said that in the beginning? Okay. Can you find the hypotenuse? Where do I find it? Because here's theta. So if I list it, it's always opposite, adjacent, hypotenuse. Ready? Yes, why are you talking? All right, where's your x? What's C? X. What's A? Sure, negative 24. Make sure it's in what? Parentheses, otherwise it's wrong. You're welcome. Plus, what's next? Negative 7, also in parentheses, with the squared on the outside. All right, x squared equals, what is negative 24 squared? 576 plus 49. You should have this done. So x squared equals how much? 625, and you should have plugged that in the calculator and found out that it is a perfect square, which is 25. So I now know that this is 25. Who had it right? Okay, go set up your trigs functions. Trigs, that didn't make sense. Trig functions. First period 2 I was trying to teach. Look at someone next to you, see if you have the chart set up correctly. If you have the chart correct, then you can do your trig functions. Check with someone next to you if you have your trig functions done. All right, ready? Let's sneeze now. All right, let's do this. Sine theta. Cosine theta, tangent theta, yes? Opposite is what? Negative 24. Hypotenuse is what? Adjacent? Hypotenuse? And then? Negative 24 and negative 7, which I know is going to end up being positive because that's what they gave me. So this one should have been super easy. You should have sine of theta equals what? Good, and then you should have cosine theta equals? And is there anything else to do with these? And call it a day. Who had them right? Good. You're going to set up the next one. You ready? Tangent theta equals negative 4 over 11 in quadrant 2. Tangent theta equals negative 4 over 11 in quadrant 2. Be careful with your signs.
Chris face and I was like, she was like, where were you? I was like, my cousin got shot. And he was like, I never heard that one before.
There's Anna.
Area.
Where's her area?
I don't know. I'm going to switch off. It's just so
All right. What quadrant are we located? 2. So we're over here, yes? And you have theta on the inside. And your tangent is what? Opposite over adjacent. So if I go opposite of theta, it's over here, which is 4, correct? And adjacent is located here, which is 11, yes? Which one's negative? Why? Because it's on the x-axis. And in this quadrant, I know the x's are what? Negative, but your y's are positive. And I learned yesterday that this is your x and this is your y. Yes? Why do I put the negative on top of the fraction when I first write it? Because it's always there. We never put 4 over negative 11. That's weird. We always move the negative to the top, right? So that's why it's here. But you need to know that the 11 is actually the negative. The 4 is not negative. How many of you remember that? Good. If not, make yourself a note. You have to watch your x's and y's. Because that's what tangent is. Nothing.
Why is everybody having babies?
Not me. Stop talking. Hey, let's do it again. Let's do this. All right, c squared equals a squared plus b squared. C is going to the wrong places. Here we go.
Important family events.
X squared equals, what's your a? 4 squared plus negative 11 squared, yes? All right, what is 4 squared? And what is negative 11 squared? Very good. What does that add it to give me? And can I take the square root of that? So what is x? Square root of 137. I don't know what I'm trying to say. It's not working. Good? Who had it right? Okay, make sense? What's next? Sine, cosine, and tangent chart. Sine theta, cosine theta, tangent theta. Oops. Opposite hypotenuse. So, Angel, you said, how did I know that was opposite and adjacent? You good? Okay. All right, what goes here? What's opposite? 4. What's hypotenuse? Radical 137. What's adjacent? 11, negative 11, yes? Make sure it's negative. All right, so sine of theta equals 4 over radical 137. Did you leave it like that? No, what'd you do? I don't know. Is she the only one who knows what she's doing? Probably. She's the only one participating. Multiply by what? Radical 137. On top and bottom. Someone in the back, tell me what you got for sine of theta. For radical 137 over 137. Okay, cosine theta equals what? Negative 11 over radical 137. Same process, correct? Okay, so you really should not have to watch me because you should already have it. So you should have, I'm out of room. Cosine theta equals what? Negative 11 radical 137 over 137. Who had it correct? Good. I'm hoping this side did too. All day long it's been this side who has not raised their hand. All right, good? All right, we're not done because it's my last part of the essential question. Pythagorean identity. So guess what we have to do? Pythagorean identity. Not number 1. Q1. What does Q1 stand for? Quadrant 1. Your answers are always positive. Quadrant 3. Answers are negative. You only deal with quadrant 1 and quadrant 3. Got it? Okay. So let's talk about what the Pythagorean identity says. Now there are trig identities you get to when you get to trig. And I think in IM2 they teach a couple of them, not quite sure, but I know they go over this one as well. This one says cosine squared theta plus sine squared theta is equal to 1. It is an identity you will manipulate multiple times when you get to trig. I think trig is fun, but I'm weird. Alright, so what's going to happen right now is this. We need to talk about what does it mean to be cosine squared. What do you think it means to be cosine squared? You're multiplying it by itself how many times? Twice. So, in parentheses, I want you to know that this means cosine theta times cosine theta. Yes, we did. Which means that sine squared theta is the same as saying what? Sine theta times sine theta. True? Okay. The reason why we write squared here is because we're taking cosine theta twice, but we're not squaring the theta. I know that's weird. It sounds weird, but we put it on this cosine, not on the theta. Okay? You don't want it on the angle. Okay. So example 2. There's only one. It says find cosine theta if sine theta is equal to 3 over 5 in quadrant 1. Find cosine theta if sine theta is equal to 3 over 5 in quadrant 1. Yes. We have 2 types of examples. Ready? Okay. So, the Pythagorean identity says cosine squared theta plus sine squared theta equals what? Yes? You have sine theta, correct? So do I have anything to do with cosine? No, because I need to find cosine. So watch what I do, just watch, and you can write in a second. So I'm going to leave it cosine squared theta. I do not know cosine, correct? It said to find it, so I'm going to end up finding it. But I do know that I have sine theta, which is 3 over 5. True? Well, if I take this and I plug it in here, what does that mean? If you have sine of theta, is sine theta squared right here? No, it's just 1, right? So if I take this and plug it in here, I then need to multiply it by what? Itself. So is that the same thing as saying 3 over 5 squared? It is. And it's still equal to 1. Good? Do you understand where that comes from? Okay. Then, Sierra says no. Cosine squared theta plus, what does it mean to be 3 over 5 squared? Means you're multiplying 3 over 5 how many times? Twice. So is that the same thing as saying 3 squared? What is that? 9 over 25 equals 1. Right? We're just going to solve this like we would any normal equation. So if I want to solve to get cosine squared theta by itself, what do I need to move? I need to subtract what? So I need to subtract 9 over 25 to both sides. True statement? Okay. So I have cosine squared theta equals. Ladies and gentlemen, if you have 1, how do you make 1 have a common denominator? What does it become? If my denominator is 25, what does 1 become? 25 over 25. True? Okay. So this is now 25 over 25, but we're subtracting what from it? 9 over 25. And you can still be watching. You don't have to be writing it if you don't want to. So what is 25 minus 9?
16. Yeah!
Over. Do you subtract the denominators or they stay the same? Stay the same. Now there's a mathematical operation that says when you have a squared, you can get rid of it. What is that mathematical operation? Square root. So I'm going to square root both sides. And when you have 16 over 25 with one big radical, remember back in, oh my gosh, August, you learned that you can go square root of 16 over square root of 25. Do you remember that? Okay. So I know that this just becomes cosine theta, right? That makes sense. Square root and square root cancel each other out. We just get cosine theta. But what does this side give me? 4 over 5. How did you get 4? Well, what's the square root of 16? 4. What's the square root of 25? 5. Am I in quadrant 1 or quadrant 3? Quadrant 1. So my answers at the top say quadrant 1 answers are always what? Positive. So my answer is going to stay positive. If I was in quadrant 3, I would go ahead and mark it negative. Do you understand? That is it. That was one big ugly fraction. That was it. Make sense? Okay. You need to write that down, because I know some of you are watching, so now you need to write it down. And I am done with notes, which means this is the last section of notes before your test next Wednesday. It'll help you study.